Hello and welcome to my channel Simple Science. This is again calorimetry chapter but continued. This is the third part of calorimetry, and in this part we are going to see change of phase or change of state and the latent heat. Now you know that an object or a matter exists in three states: solid, liquid and gas. Now if we take solid ice, on heating ice melts and becomes water. Now water, if you heat water, what will happen? It will start boiling and it will get converted into vapors. Now vapors on cooling, what happens? They will again convert into water in the liquid form. And liquid form, that means water on cooling, again it becomes ice or it takes solid form. That means when solid is converted into liquid on heating, that process is called melting, and in this process heat is absorbed by the solid. And liquid on heating becomes gas or vapor. The process is called boiling or vaporization. Now when gas is cooled or when heat is released, it becomes liquid and the process is called condensation. And when liquid is cooled and becomes solid, the heat is released and the process is called freezing. So these are the change of phases or change of state of matter. On heating, solid becomes liquid. On cooling, liquid becomes solid again. And these are the process. There is one more process where solid directly gets converted into gas or vapor state without changing into liquid. That is called sublimation. That process is called sublimation. And if a vapor directly gets converted into solid without changing into liquid, that process is called solidification. Now in this video we are going to see what happens during the change of state. That means what happens during melting or freezing. So basically we will focus here on melting. What happens during melting of ice. Now the term is latent heat, which I am going to explain you. What is latent heat? Take a few grams of ice or 200 gram, 20 grams, say 20 gram of ice. Now suppose the ice is at minus 20 degrees Celsius. The temperature of ice is minus 20 degrees Celsius. Now you provide heat to it. When you provide heat to it, what happens? Because of heat, the temperature of ice will increase from 20 degrees Celsius to 0 degrees Celsius. But at 0 degrees Celsius, the temperature does not increase even though heat is supplied to it. Then where does this heat go? This heat goes in breaking the bonds of solid ice to convert it into water. So this heat is called latent heat. The heat which is required or which is used for the process of melting of ice or melting is called latent heat. So latent heat is nothing but heat energy only, but this heat energy is used for the process of melting. Why it is latent heat? Why it is called hidden heat? Because heat is used but temperature does not increase. Temperature remains same during the process of melting or during any change of state. The temperature remains constant. Suppose the change of state is from solid to liquid. Until the whole solid gets converted into liquid form, the temperature will not increase. And when liquid gets converted into solid, the temperature will remain same until the whole liquid gets converted into solid. Now suppose if I increase the mass of the ice, will it take same time to melt? No, it will take more time because mass is increased. So this latent heat Q is nothing but latent heat, depends on mass. So latent heat is equal to this should not be proportional, this should be equal. Q is equal to ml. And what is L here? L is called the proportionality constant, which is called specific latent heat. Q is the latent heat and L is the specific latent heat. And specific latent heat from this formula will be equal to Q upon M. Now let us study about specific latent heat. What is meant by specific latent heat? Now specific latent heat from the previous definition or from the formula L is equal to Q upon M, where Q is the latent heat or the heat required for melting. So specific latent heat is also the heat required for melting, but by unit mass of a substance. So specific latent heat of a phase is the quantity of heat absorbed or liberated by unit mass of a substance for change in its phase at a constant temperature. Now what is specific latent heat? It is nothing but heat required. Heat required by unit mass. Unit mass means 1 gram or 1 kilogram of a substance at a constant temperature. So what you have to remember here, what is specific latent heat? It is nothing but heat required. Heat required for what? For change in state by unit mass of a substance at a constant temperature. Now, specific latent heat of fusion of ice. What is specific latent heat of fusion of ice? It is nothing but the amount of heat absorbed or the quantity of heat absorbed by unit mass of ice to change into water at constant temperature. So, specific latent heat of fusion of ice is nothing but heat required by unit mass of ice to become water at constant temperature. Now, what is the value of specific latent heat of ice? Value of specific latent heat of ice is 336 joule per gram. What do you mean by this? If the question comes like specific latent heat of ice is 336 joule per gram, what do you mean by this statement? That means 1 gram of ice will absorb 336 joules of heat energy to become water or to completely melt at a constant temperature. During the change of state, temperature remains constant. Now the specific latent heat of ice in kg is 336,000. That means 336 into 1000 joule per kg. What does it mean? It means 1 kg of ice will require 336 into 10 to the power 3 or 336 into 1000 joules of heat energy for melting at a constant temperature. So I hope you have understood the meaning of specific latent heat. Now we will see the heating curve of ice. What happens when ice melts, how much heat energy it absorbs. So for that, to draw heating curve of ice, we'll draw one line on y-axis and one line on x-axis. On y-axis we will take temperature in degrees Celsius and on x-axis we will take time in seconds. Now suppose the initial temperature of ice is minus 20 degree Celsius. Now let this point be A. Now on heating it will absorb heat. So as the time increases, its temperature will increase. Now suppose its temperature increases and it reaches B. From A to B, the ice is in solid state. And the heat absorbed by ice will be equal to mc delta T, because there is change in temperature, rise in temperature, so mc delta T of ice. At B, the temperature does not increase, time is increasing. You can see that time is increasing but temperature does not increase. What does it mean? Let the point be C. That means this is the melting point of ice. That means the process of melting takes place. So from B to C, the process of melting is taking place. So ice is both in solid and liquid form. And this temperature will not increase until the whole ice becomes water. Now what is the heat absorbed at this point between B and C? Since there is no rise in temperature, no delta T. Now here we will use the formula of latent heat, that is ml. So Q2 is ml. Now when the whole ice gets converted into water, the temperature will increase. Now suppose now it reaches a point D. Now from C to D, the heat absorbed by, now I will not say ice because it has become water, is mc delta T of water. Now again at D, again the temperature remains constant. That means the process of boiling is taking place at 100 degree Celsius. You don't have boiling curve. You have only till a melting point or specific latent heat of fusion. You don't have specific latent heat of vaporization. So we will not focus on boiling curve. We will only focus on melting curve of ice. So Now this is about heating curve of ice. Here the heat is absorbed in 3 stages: Q1, Q2 and Q3. Heat is absorbed for converting solid ice at minus 20 degrees Celsius to ice at 0 degrees Celsius. Now then heat is absorbed for melting of ice at 0 degree to water at 0 degree Celsius, and then from water at 0 degree Celsius to water at 100 degree Celsius. Now the specific heat capacity of ice is 2.1 joule gram power minus 1 Kelvin power minus 1, and specific heat capacity of water is 4.2 joule gram power minus 1 Kelvin power minus 1. Water takes more heat. That means in this case the specific heat capacity of water is more than specific heat capacity of ice. That means ice will absorb less heat for same rise in temperature, unit rise in temperature, as compared to water. Now let us take one question to understand this kind of questions. Basically graph questions. Now take 200 gram of ice at minus 20 degrees Celsius and calculate the amount of heat required or absorbed to convert it to water at 80 degrees Celsius. So what is given here? There is ice, 200 gram of ice, which is at minus 20 degrees Celsius, and you have to provide heat. Heat is given to it, so it will absorb heat until it becomes water at 80 degrees Celsius. Specific heat capacity of water is given, for ice is given, and specific latent heat of ice is given. All these are constant values. It will be given in the question, or otherwise you can learn also. You should know this in gram and in kilogram also. Now ice is at minus 20 degrees Celsius. So its temperature, when heat is provided, its temperature increases and it will reach 0 degrees Celsius. Now between A and B, it will absorb heat Q1, which is equal to mc delta T of ice, where m is mass of ice, c is specific heat capacity of ice, and delta T is change in temperature of ice, which is minus 20 to 0. That means 20. So Q1 is equal to 200 into 2.1 into 20. Now at B, the process of melting is taking place. So from B to C, the process of melting takes place at temperature 0 degrees Celsius. So here we will use the formula ml. Q is equal to ml. So mass is 200 gram and L value is given in the question. Substitute the value. Now when the whole ice gets converted into water at C, from there the temperature will increase up to 80 degree Celsius. Now heat absorbed in this case will be Q3 mc delta T, which is equal to m is given 200, mass will remain same, and C of water is 4.2, and change in temperature is 0 to 80, that means 80 degree Celsius. Now substitute all the values. So the total heat absorbed is in 3 stages. Q is equal to Q1 plus Q2 plus Q3. So you have already calculated Q1, Q2 and Q3. So the total heat absorbed you can calculate from this. Easy. Now we'll take one more question. Take 200 gram of ice and calculate the amount of heat required or absorbed to raise its temperature to 30 degrees Celsius. Now in this question the temperature of ice is not given. That means you have to consider that ice is at 0 degrees Celsius. So ice temperature of ice is not given, minus 10, minus 5, minus 20. It's not given in this question. That means ice is at 0 degrees Celsius. You have to consider. Now ice is at 0 degrees Celsius. So first it will melt. It will become water at 0 degree Celsius. So heat absorbed in this case, Q is equal to ml. Then its temperature will increase and it will go up to 30 degrees Celsius. And then in this case the heat absorbed will be mc delta T, where m is mass, c is specific heat capacity of water, and delta T is change in temperature from 0 to 30, rise in temperature. So now Q is equal to Q1 plus Q2. Here only 2 stages where heat is absorbed because ice is already at 0 degrees Celsius. So that is equal to, substitute the values and do the calculation and you will get your answer. I hope you have understood. If you haven't understood, if you want to calculate it yourself, pause the video and please go through it once again. Thank you. Like, share and subscribe my channel. Take care.